This is my first long-form video in a while. So this is my 3D printed 2-cylinder air engine. It has an electric start, and then the electric start generates DC power off of a 130 motor to a bunch of LEDs I have wired in parallel, and it's pretty powerful. So this engine is pretty powerful with a calculated horsepower of 0.4 horsepower at 30 psi. That's calculated with the amount of force being put down onto the piston and the torque being generated along with the RPM. So it's not perfect, but that's around how much I think it has. I don't know the exact RPM this motor runs at, or the exact RPM that electric DC 130 motor needs to generate the 4 volts that it's putting out right now to power the LEDs. But I'm pretty sure that this engine, while running at generating RPM, runs at about, my guess is probably 1,000 something RPM, like mid to low 1,000 RPMs. But I can push it to 40 psi while running, and it just drains the pressure straight out of the air tank. So I'm pretty sure that it can hit around 3,000 or 4,000 RPM, but I just don't need it to when I'm generating low amounts of power like this. In the future, I plan to have a more powerful way of generating power, because this is really inefficient for the amount of power that I'm putting in. I want to make a probably 3-phase generator, wind the coils myself, and then use a G2T timing belt like the ones used on my 3D printer as a drive for it with a gear ratio, so that it spins faster, slower, don't really know yet. And then generate some higher voltages, like maybe 12 or 24 volts, and then rectify those voltages to create DC power and use that. Because I know that I'm not getting all that I can get out of it. So this engine idles really smooth and runs really smooth, and is overall a pretty good engine, but it needs a lot of oil. So this engine, about every 15 minutes of running, I take off that valve split cover that covers up all the splits in the air intake, so then both cylinders get air. And I fill each of those little stacks up with oil, then use the starter motor to turn it over for probably 100 revolutions, and then I give it power. And it's pretty cool because it sprays oil and it looks like smoke, like it's a cold startup. When it's oiled well and lubricated and everything, it idles and sounds like a real engine idling, because there's not that awful low-end squeak that I get with it. I wish that I could find an easier way to get rid of it, but I'm pretty sure it's just something that happens between the two plastic pieces rubbing together. So this engine has a 180-degree cylinder offset, so while one piston is at the top firing, it has another piston at the bottom just waiting to be at the top to fire, which allows one piston to open up the other piston's air valve, allowing for a lot smoother running because it doesn't rely on a flywheel's inertia to kick open the valve. So for valves, this engine uses a push rod that pushes open a 6mm plastic BB inside of a rubber O-ring with an inner diameter of 5mm and an outer of 9, which allows for really high airflow compared to my other engines, which use a 4.5mm, so the head of the bolt could barely fit through. So that's another reason why this engine runs so well, and also has a more throaty sound while running. So overall, this engine's powerful, pretty efficient, because it can run on legit, the regulator will be reading 0 psi and it'll still be running, and it also can hit some high RPMs. I haven't messed with the timing yet, which I should and tune it for high RPMs and just see how much I can push it. But I just don't really have a need for that right now, and I'm kind of burnt out from all the stuff I've been doing with it.